Okay, welcome to a sort of surprise geometry lecture. I got a question from a former student of mine, Andrew, after watching the lecture on section 1.2 of Geometry Revisited. So the question from Andrew was, on Chivas theorem, or Chaves theorem, if the intersection point of the Chevians is outside of the triangle, does Chivas theorem still hold? So, actually an interesting question, and lucky for me I got this interesting question, and lucky for Andrew, I was actually taking the day off of work today anyway, so I thought I'd try to work through this because, to tell you the truth, I have no idea. So, recall Chivas theorem. It says in a triangle ABC, and I'm sorry the picture is so complicated here, but having worked through it I had to leave the picture up. Here's our triangle ABC. Chivas theorem says if the Chevians intersect in a point, in one point, then we have bx over xc times cy over ya times az over zb equals 1. And if you want a little refresher on Chivas theorem, go back and look at Geometry Project 2. So, let's take a look at this triangle that I've drawn here. And to tell you the truth, one of the hardest parts about figuring this out was just getting the picture right. Let's look at the Chevian from A, and again the triangle is ABC here. And the Chevian from A meets BC extended here at X. So here's the Chevian X that gets extended down this way. And the Chevian from B meets AC extended at point Y, and then meets the Chevian AX at the point P. And now we have the Chevian from C that meets AB at Z and extended backwards intersects at this point P. So here's my triangle, ABC, drawn in purple. The Chevians are drawn in green, AX, BY, and CZ, and they intersect at P. And the question to try to figure out is, does BX over XC times CY over YA times AZ over ZB equal 1? So, following the notation in the proof of Chivas theorem the first time around, and if I put the camera over here, you can see what I'm going to try to do. We're going to take a look at what BX over XC equals. So what does BX over XC equal? BX is this line here, and XC is this small line here. So the first thing we notice is that BX and XC have a base here and a height going up to A. So if we look at the triangle ABX and AXC, those two triangles have the same height, and we know that BX over XC is the ratio of those two triangles, of the area of those two triangles, the triangles being ABX and AXC. But also notice that BX over XC gives us the ratio of these other two triangles, PBX and PCX, or as I've written it, PXC. Because again, those triangles have a height going up to P, and one has a base BX and the other has the base XC. So we now know, and I'll go over to the algebra over here, that BX over XC equals the area of triangle ABX over AXC and PBX over PXC. Now, if you go back and look at the original proof of Chivas theorem, what we did is we subtracted those two triangles away. But it turns out, with the intersection point on the outside of the triangle, instead of subtracting those areas, we need to add them. So we add those two areas together here. We take triangle ABX plus triangle PBX, and we get the triangle ABP. And we take the triangle AXC and PXC, and we get the triangle CAP. So BX over XC turns out to be, that ratio turns out to be the same ratio as ABP, the area of triangle ABP, over the area of triangle CAP. And that's nice. So we just have to do one little trick in addition to drawing the picture right, we had to do one little trick, which is instead of subtracting those areas, we had to add them. Now you can follow the math as well, and Andrew, I'm sure you're going to go back and do this, to find that cy over ya, let's go back over here, cy over ya, and notice that leg, AC, and then extended to y, is, we're talking about this achieving here, b to y to this intersection point P. And notice that, as before with x, y is outside of the triangle, and because of that, it turns out, instead of subtracting the areas as we did in the original proof, we have to add them. So we look at the ratio of those two, of CBY, ABY, C, we add them, and we get the triangle, that ratio, CY over YA, equals the ratio of the areas of triangle BCP over ABP. And finally, if you go back and we look at AZ over ZB, which is here, AZ over ZB. Now notice Z is inside the triangle now, or at least in between A and B. I guess it's not technically inside the triangle, it's in between A and B. Which means for that one we just follow the same procedure as in the original proof of Chavis theorem. We subtract the area of the triangles. And at the end of the day, after going through all of that math, Andrew, what we end up with is bx over xc times cy over ya times az over zb is the ratio of abp over cap times the triangle area bcp over abp times cap over bcp. Cancel, 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 cancel. And lo and behold, it still equals 1. Now that's only one half of the proof. That's the if proof. And Andrew, I will leave it as an exercise for you to do the only if proof. But it appears to me, the short answer to your question, Andrew, is yes, Chavis theorem appears to hold even if the intersection point of the Chevians is outside of the original triangle. Great, thanks for the question, Andrew.